Hello everyone, how are you all? I hope you all are having a great day so far, right? Okay, so I welcome once again everyone to the next part of units and dimension. Okay, so in this class we will discuss here about the application of dimensional analysis. So now let's begin with our second part of units and dimensions. So first of all, so we have mainly three applications of our dimensions, that is to convert a physical quantity from one system of unit to another one. Okay, from one system of units to another. We will discuss about that in the upcoming slide. Next, to check dimensional correctness of a given physical relation. And the third one, to derive relationship between different physical quantities. Now everyone, please concentrate here because today class will be very important. Okay, now, so first of all, we will discuss here about the first topic, which is the conversion of unit. Okay, and if you remember, yesterday we have discussed about this formula n1 u1 is equal to n2 u2, and I said that we will discuss about that in today's class. Okay, so to convert numerical value of a physical quantity from one system of unit to into another system of unit. Okay, so first of all, we have discussed earlier, that is the magnitude is equal to numerical value into unity, and that is a constant value. That means n into u, that will becomes constant. Okay, and we know the formula n1 u1 is equal to n2 u2, where n1 is our numerical value in first system and n2 is our numerical value in second system. So we have one example here. We have to convert 1 Newton into dyne, that is the CGS unit. So first of all, we know the dimensional formula of force, that is m1 l1 and t to the power minus 2. Now we will use the formula n1 u1 is equal to n2 u2, and we have to find n2, right? So n2, that will be equal to n1 u1 upon u2. So n1, now first of all, we know that we can't cancel out from kilogram to meter, right? We can only cancel out kilogram to gram, like we can convert kilogram into gram and then we can cancel out. Okay, so that is why we have written over here m1 m upon m2 to the power a, l1 upon l2 to the power b, and t1 upon t2 to the power c, because we can't cancel different units from each other. So first of all, n1 m1 upon m2 to the power 1, because you can see that m to the power 1, l1 upon l2 to the power 1, and t1 upon t2 to the power minus 2. Now what is m, which is mass, right? So in the first ASI unit, our mass is in kilogram, but in CGS it is in gram. Then in SI it is a meter for length and centimeter for our length as well in CGS. Okay, and then second in SI also and in CGS as well. So we can write it down 1 kilogram upon gram, meter upon centimeter, and second upon second to the power minus 2. Now we know that if you are just cancelling this, so what you will get? This is 1. Why it is 1? Because see, n1 is equal to 1. n1 is equal to 1. So 1 kilogram upon gram will give you 1000, because we can say 1000 gram upon gram. It will cancel and you will get 1000. That is why it is written over here 1000. Similarly 100, because 100 centimeter upon centimeter, and you will get 100 and then 1. So that will be equal to 10 to the power 5. So we can say 1 Newton is equal to 10 to the power 5 times. I hope you all have got it, and if you have some doubt, I repeat once again that you can post your doubt in the comment section. Okay everyone, in the comment section. Now we will move to our next slide. So the second thing, which is to check the dimensional correctness, that we have discussed earlier regarding the applications of our dimension analysis. So we will take one example. We know the formula T is equal to 2 pi root over L by G. So what is the dimensions of T? We know it is m0, l0, and t to the power 1. So this is the dimensions of left hand side. So if we can get the dimension of right hand side, and that is equal to m0, l0 and t to the power 1, then we can say that it is dimensionally correct. Okay, l0 t to the power 1. So first of all, let me erase a few things from here. Give me a second. Wait. Okay. So now you can see the dimensions of left hand side, which is the time, m0, l0, t to the power 1. Dimensions of right hand side, see, 2 pi is a dimensionless quantity because it's a constant term. So we have to find the dimensions of L upon G to the power 1 by 2 because the root will convert into the power and that becomes 1 by 2. So L, and we know the dimensions of G. Dimensions of G is L t to the power minus 2. So it will become t to the power 2 and whole to the power 1 by 2, and that will be equal to m0, l0 and t to the power 1. So you can see the dimensions of RHS is equal to dimensions of LHS. So we can say that it is dimensionally correct. I hope you all have got it. Okay. Now the third one, to derive relationship between different physical quantities. Now how we can do that? So we have one example here. First of all, we know time of revolution t of a satellite around the earth that depend upon few things, which is gravitational universal gravitation, which is g, mass of the earth m, and radius of the circular orbit r. So we can say that t is directly proportional to g, m and r. Okay, and let's say they have the dimensions, dimensional power a, b and c. We know the dimension of our universal gravitation, capital G, and that is equal to m minus 1, l3 and t minus 2. Okay, so now you can see here dimensions of t, which is m0, l0 and t1. And if I am saying that dimensions of capital G, which is m minus 1, l3 and t minus 2 to the power a, dimensions of m, so that we have not written over here because it's a mass, so m to the power b and l to the power c for radius. Now if you equate all these powers here, so what it becomes? M to the power minus a, l to the power 3a, you can see m to the power minus a, l to the power 3 into a and t to the power minus 2a, then m to the power b and l to the power c. Now if you just equate this thing, it will become m to the power b minus a, l to the power 3a plus c and t to the power minus 2a. Okay, so now we are comparing the exponents here. So if I am finding for time, so you can see in the left hand side that t power is 1. Okay, and in the right hand side t power is minus 2a. So we can say 1 is equal to minus 2a. So a will be equal to minus 1 by 2, right? Now if you are finding for m, so for m you can see in the left hand side m exponent is 0 and in the right hand side m exponent is b minus a. So we can say 0 is equal to b minus a, so b is equal to a, and we know a is equal to minus 1 by 2, so b will also equal to minus 1 by 2. Similarly for L, so you can see the L exponent in the LHS is 0, but in the RHS it is 3a plus c. So we can say 0 is equal to c plus 3a. We can put the value of a here, which is equal to minus 1 by 2. So c will be equal to 3 by 2. C will be equal to 3 by 2. Now you can see we can equate the powers now. So now we know that t proportional to g to the power a, m power b and r power c. So just equate all the powers here. So we can say t proportional to g to the power minus 1 by 2, m minus 1 by 2 and r 3 by 2. That is the value of a, b and c that we have found in the previous slide. So it will be equal to root over r to the power 3 divided by gm, and this 1 by 2 will become the root, right? So root over r cube upon gm. So this is the use of our dimension analysis. You can see dimensions of some mathematical function like derivative, and double differentiation. So that is equal to m0 l1 t minus 1 and m1 l1 and t minus 2. Similarly, now there are some limitations of this method. What are the limitations? First of all, in mechanics, the formula of a physical quantity depending on more than 3 physical quantities that cannot be derived, it can only be checked. Okay, it cannot be derived by this dimensional analysis, it can only be checked. Second one, this method can be used only if the dependency of a multiplication type. Okay, if it is only of multiplication type, the formula containing exponential, trigonometrical function, logarithmic function, that cannot be derived using our dimensional analysis. Okay, so using this method, now formula containing more than one term which are either added or subtracted, like s is equal to ut plus half it square, can also cannot be derived. So that is also a limitation of our DA. Now if dimensions are given, physical quantities may not be unique as many physical quantities have the same dimension, because we have seen few physical quantities have the same dimensions. So with the help of DA, we cannot differentiate them, right? So we can say that the dimensions, if the dimensions are given, physical quantities may not be unique as many physical quantities have the same dimensions. Okay, now it gives no information whether it is a scalar or a vector. So these are the limitations of our dimensional analysis. Okay, so I hope you all have got it, and once again, if you have some doubt, you can post your doubt in the comment section. Okay everyone, so take care of yourself and keep learning, and please do subscribe to my channel. Okay, it will help you as well and help me as well. It will give me more motivation to make more videos like this. Okay everyone, so take care and bye.